Hey guys, this is an examples video of using the exponent rules, but with just numbers, no variables. So I'm going to go through these 6 examples. You can pause the video if you want to read it over or quiz yourself or whatever. So I just want to kind of show you different ways that you can approach problems like this, how you can do it with the order of operations like versus exponent rules. Okay, so let's jump into it. So starting here with A, so I just want to point out there's 2 different ways that you can do this. So in this particular example, you could use the order of operations or you can use exponent rules. So if I wanted to use exponent rules, so notice that this is the same base of 3. So I know just by looking at this that I could add the exponents that are attached to the 3. So I could think of it like this. So this is really just 3 to the third, which equals 27. So that's one way that you can do this, or you can use the order of operations. So the order of operations would say that first I have to evaluate 3 squared. So 3 squared is 9, and then I have to multiply that by 3, so that still equals 27. So sometimes you'll get questions like this, and so if you're not quite sure what they're asking for, like if they're asking you to give a, to just use rules of exponents, this would be the way that you want to go about it. If it doesn't matter, you could really use either approach. Okay, so this is now just more of a general exponent review, what is happening here. So this is just to remind you of what happens when you have the parentheses and a negative. So when you have the parentheses, you think of this as -4 times -4. -4 times -4, that'll be positive 16. And then you'll multiply that by 2. So this equals 32 in this case. And in this case, you can't really use like an exponent rule because they don't have the same base. Okay, so now let's contrast that to C here. So in this one, we could do this one of 2 ways. So I could use the quotient rule, which would mean that I would take the 7 minus the 4, and then this would just be 2 to the third, which is 8. Or I could use the order of operations. So if I wanted to go that route, so 2 to the 7th is 128, and then 2 to the 4th is 16. And 128 divided by 16 is equal to 8. However, I think sometimes when people are thinking through like their mental math, maybe you don't remember what 2 to the 7th is. That would just take you a while to calculate. So I think in this case, you can actually see the benefit of using exponent rules to help you kind of evaluate this, right? So in some cases, like this one, it doesn't really matter which way you want to go, but in other cases, like there might be a major advantage to using exponent rules. So that's kind of the point I wanted to make. Okay, now for this one's kind of interesting because we can kind of see some exponent rules here. So first of all, to evaluate this first part, we want to think about this as 2 to the third over 3 to the third. Okay, so you can actually see already that you could technically make some cancellations here. Depending on whether or not you've learned about negative exponents, that can kind of drive what you might want to do next. So here's the thing I want to point out. This is the way that I would think about this if I want to use exponent rules. So you've got 3 to the third and 3 squared. Now this 3 squared is technically over an invisible 1, right? So where are there more 3's? On top or on bottom? There are more on bottom. So if you're doing a cancellation, in this case, your 3's would actually end up at the bottom. So I'll show you how this would work in exponent rules. So I still got this 2 to the third up here, but I'm going to have this 3 to the third minus 2. And the reason I actually did it like this, so this will also be explained in like a negative exponent video, but the reason I did this is because there's more 3's on bottom, so that's really where your answer should be. So this will equal 8 over just 3. That's it. Now, if you wanted to use this using the order of operations, if that was kind of confusing, then you can just go, so this 2 to the third, 3 to the third, and then 3 squared. So check this out. This is going to be 8 over 27 times 9. Now I can see by looking at it like this, so this 9 is over a 1. I can divide out this 9 and this 9. So ultimately I will still get, this will be 8 over 3 times 1 over 1. So this is just 8 over 3. So there's a couple different ways that you can kind of look at these. So that's kind of what I'm trying to get you to see in this video, I guess. Okay, now here with e, we can't use necessarily an exponent rule with this. We would just have to evaluate it as is. 6 squared is 36. 2 to the third is 8. But notice here you can actually make some cancellations. So both of these are divisible by 4. So if I divide this by 4 and divide this by 4, let's see, I'm going to get 9 over 2. And now finally for this one, so this one's kind of similar to that like 2 examples ago that we were looking at. So if I want to use exponent rules, I can. So I can think of this as 1 to the 4th over 2 to the 4th, and then this is still 2 squared. And once again, so remember that 2 is over, this is over an invisible 1. And then there are more 2's in bottom than on top, so that tells you that your exponents have to end up in the bottom. So if I wanted to do this from the standpoint of exponents, I would take this 4 minus this 2, so this 4 minus this 2, and it all ends up in the bottom. So this would be 1 over 2 squared, so this would be 1/4. But again, if you find that kind of confusing, what you can do then is you can just use the order of operations to evaluate this. So this will be, this will be, let me erase all of that. 1 to the 4th over 2 to the 4th times 2 squared. So I could just evaluate all of these separately. So this will be 1 over 16 times 4. And now I can see, so this 4 I know is over an invisible 1. I can divide this by 4 and this by 4. So this will give me 1 over 4 times 1 over 1, which just equals 1/4. So whichever way you want to think about it is fine. I just wanted to kind of show you different ways you could think about using exponent rules for this. So that covers it for this video. Got any questions, you can leave me a comment. I do have other example videos if you were looking for ones with variables. And I also have a whole lesson video where I break down all the exponent rules. So thanks for watching, guys. I'll talk to you next time.